In this video, our focus shifts to Module 3, where we shall be considering the topic Probability Theory for Decision Making. Our goal is to explore what methods are used to quantitatively assess the amount of risk involved in any decision-making process. In order to understand how this is done, we need to first go back to the very foundations, and that is rooted in the concept of probability theory. To get started, let us consider an informal introduction to probability. And informal as it is, we'll consider a bag here on your screen. So here is what it means. If, for instance, we consider different events, the event of drawing a red marble from this bag, considering that we have only blue and white marbles in this bag. Would you describe this event of drawing a red marble as a likely event, an unlikely event, maybe an impossible event, or a certain event? What do you think? Well, I will think that since this bag only contains blue and white marbles, the event that I'll draw a red marble out of this bag would definitely be impossible. So in other words, even though I am going to put my hand in this bag, the chances that I have of drawing any marble, I have about 10 chances of drawing any marble. So out of 10 chances of drawing any marble, I stand a 0 chance that the marble I will eventually pick is a red marble. So I'll call that what? 0. In other words, I've used fractions to quantify numerically the likelihood that I'll pick a red marble. What about drawing a white marble? How many chances do I have of picking a white marble? Well, this is one chance if I drew this marble. If I drew this marble, this is another chance. So I stand a 2 out of 10 chance of drawing a white marble. Then again, for a white marble, we can make a similar argument that each of the 8 blue marbles here presents a chance of drawing a blue marble. In other words, out of any 10 possibilities of drawing any marble, I stand 8 of drawing a blue marble. Then finally, what are the chances of drawing a blue or maybe a white one? Anyone, acceptable. What do you think? Well, out of 10 marbles, there are 10 chances of drawing either blue or white. Anyone is acceptable. This is same as 1. The point I want to make here is simple. We can go from the events that would never happen, aka an impossible event, to an event that as long as I'm dipping my hands into this bag, then I am certain to draw either a blue or white marble. So I am going to a certain event. It appears that when we use numbers to quantify the chances that an event will occur, we can use numbers between 0 and 1 because whether an event gets to happen lies between the extreme of it would never happen and it will surely happen. This sets us up for how we use numbers to quantify the chances or the likelihood that an event will occur. So as it is, we start off from an impossible event and we can go as far as a very certain event. The closer that fraction is to 1, the more likely it is, and the closer it is to 0, the more unlikely it is. So as far as probability is concerned, informally speaking, it involves using numerical values, and otherwise, most times we use fractions to measure how likely a particular event or outcome will occur. So in general, probability values will usually be from 0 to 1. Whenever you compute probabilities, we should never get a negative value, and neither should probabilities exceed 1. Where any number between these two numbers helps to reflect the certainty or otherwise the uncertainty of the event occurring. What about a formal perspective to looking at probability? Let us consider an example of the formal perspective. A die, the singular of a dice, is a cube with 6 faces numbered 1 to 6. What is the chance or likelihood of getting a 1 when you roll that die? What do you think? Well, the die has what? 6 faces. So 1, 2, 3, 4, 5, and 6. Well, what are the chances that I will get just the 1? That is this guy. That is just one slice out of 6 possible slices. In other words, the chance of getting a 1 when rolling this die is 1/6. Let's think a little bit deeper about this number. Does it mean that if I toss or throw this die, toss a die, let's say 60 times, if we're talking about a fair die, are we saying that 1/6 of the times, are we saying that 1/6 of the times, or 1/6 of 60 times, which is 10 times, that we're going to get exactly a 1? What do you think? In reality, that rarely happens. There will be some variabilities. Well, the point we're trying to make ultimately is that when we define the probability of getting a 1 as 1/6, it means that if we actually carry out the, the experiment, the process of rolling that die a large number of times, not a small number of times as in the case of 60, we'll get that 1 approximately 1/6 of the times. Simulations can prove this, and that is if humanly we're not able to do it. So the definition of the probability of an outcome, such as getting a 1 when rolling a die, is the proportion of times the outcome will occur under the condition that we'll carry out that experiment a large or almost infinite number of times. In this video, the goal was to introduce a formal and informal perspective to the understanding of a number that represents probabilities or the quantification of the likelihood of occurrence of that event.